Let's approximate the sum of the series below by its first 6 terms. Before we do, I want to go through a step that is generally not needed every single time, but I do want to point out that this, where we estimate the sum of a series, well, that's if the series converges, right? What if the series diverges? Then you're not going to have a sum. It's going to be infinity. So just briefly, don't have to do it all the time. Don't have to copy a thing right now. I'm just going to confirm that this alternating series converges by using the alternating series test, and that would be a two-parter. The limit as n approaches infinity of the positive aspect of this, taking out the toggle factor, I call it, and this should equal 0. Check. Mission accomplished on part 1. And then we also need to confirm that this is true. That basically means that the next term is always less than or equal to the current term. It needs to consistently happen that way. And we're just going to confirm that very quickly before we move on to the actual question. N plus 1, and then 2 over square root of n. And I want to just make sure that I can put the less than or equal to symbol in here. First of all, it won't equal, but it will be less than. And the reason it's less than is because this denominator will consistently be greater, so the fraction itself is less than. So yeah, confirmed. This truly does converge, and we move on. In case you care, it actually converges conditionally, not absolutely, because this would be a p-series. Oh my goodness, I'm off topic, but let's keep going. If I only treated it as if it was positive, then we would have this, which is that, which is a p-series where p equals a half, and because 1/2 is between 0 and 1, this is going to diverge, which means the alternating series converges, the absolute value of it, the positive aspect, would diverge. Therefore, the alternating series converges conditionally. It will not consistently converge regardless of its sign. Only converges if it's alternating. Okay, now let's do the actual question. The actual question is one in which we need to approximate the sum of the series below by its first 6 terms. Okay, let's write a formula. Let's use green. No, black. Man, I wanted green. Absolute value of s minus s sub 6 in this case is less than or equal to the 7th term. Okay? And I say 7th term, and I mean 7th term meaning the positive aspect of the 7th term. So this is like the toggle factor times a sub n. So there's your toggle factor, and then 2 over the square root of n is the explicit part of it. Okay? So we're going to find the sum of the first 6 terms, and we're going to use a little feature in the calculator to do so, because this would definitely be a calculator active question. Because, yeah, good luck trying to figure that out otherwise. And that's going to be less than or equal to the 7th term. So let's do this. I'm going to type this in, so y equals, and we're going to type it in for what it is. And let's go -1 to the x plus 1. Times 2 divided by the square root of x, and everything looks good to me. And I paused to make sure everything looks good because I would really hate to have a glare on the screen where you couldn't see it. I would really hate to leave some parentheses off that would be able to separate the numerator and denominator, but it's not necessary in this case. We don't have a binomial or anything like that, or an extra term in the denominator. Off topic very quickly, if I had 2 square root of n, I would need to put in the parentheses 2 square root of x, because I'm dividing. Okay, anyway, I want to add together the first 6 terms, and I also need to find the 7th term. Let's actually go ahead and aim for the 7th term. I think it'll be pretty easy. And so let's go to, well, 7. I went to the table, and I'm going to do that. I'm going to go crazy with my decimals, like 3 is sufficient, but I'm in the process of doing something much larger in terms of estimating an infinite series. So I'm going to go crazy with my decimals. 559. 289 I think is sufficient. I just wanted to go a little further than normal, and I didn't leave too much room here, but we'll do it. So let's also find the sum of the first 7 terms, and here's how we're going to do it. I'm going to press second and list. There we go. I'm going to go over to math, go down to sum. I want to add together a bunch of numbers. I want to add together a sequence, and that sequence, second and list, go over to ops. And the sequence is what? Okay, think carefully here. What expression am I using? I'm using that which is stored into y1. What's my variable? I'd love to say it's n. The way I saved it, actually, it was x. Where do I start? 1. Where do I end? 6. Step. What do I mean by step? Well, how far up do we count? Well, we're counting up by 1 because we're dealing with integers. And then I paste that in there, close parentheses. Don't have to in this case. This operating system works well without it. Press enter, and that's it. So let me white that out, and then negative 0.8184176. I'm going with 7 decimal places because I feel like it. Now, you're probably going to be a little bit disappointed when you see this estimation for the infinite sum, but here goes. S minus 0.8184176 less than or equal to 0.7559289. Do I have to use all these decimals? No. Why am I doing it? I just want to. I really want to. I'm in this context, just with me personally, I like the accuracy, but that's just me. It's not necessarily required. We're going to add that number to that one, and it's going to give me a pretty wide range here. Here we go. Oh, let's be exact. You want to be exact? Well, as exact as the calculator can be. Look familiar? Okay, sounds good. That, by the way, I pressed second enter, pulled it back up. Plus, I'm going to scroll up and get that. That was the sum of the first 6 terms. That's what I would get if I added that over here. So 1.574. 1.574. Keep going if you want to for consistency with what I've been doing. I think I will. 6.5. And then we'll do the same thing here. So negative y of 7, or the 7th term. I'm going, pressing second enter, pulls up the last thing, insert a negative, and then we're going to add that last thing. And we get this. 0.062, keep going with that if you like. So 0.0624886. Okay, I'm estimating my sum, and on the previous problem, I had a pretty narrow range between 0.76-ish and 0.84. Pretty narrow. This is a little bit of a wider range. Quite a bit wider, actually. So a little disappointing. If I wanted it to be more accurate, I could go more than 6 terms, but I didn't.